Word embedding is an important technology for machine learning and natural language processing. It maps discrete objects to a continuous space where their locations are effectively visualized. For example, if you embed words, son, boy, daughter, girl into a real space, you can realize vector calculation among them. The important question is, how do you choose the dimensionality of the space for embedding? If the dimensionality is too low, then the words cannot be discriminated well. Meanwhile, if the dimensionality is too high, the words are so highly separated so that their locations are too much affected by data, then it is not possible to infer future words from the context. Therefore, the optimal dimensionality exists. In the area of natural language processing, this problem is well known. However, there was no work on systematically solving it. In order to solve this problem, we noticed that the probabilistic model for word embedding involves the matrix factorization, which represents a signal matrix as a factorization of two matrices where the dimension for the embedding equals the rank for the matrix factorization. Our key idea for dimensionality section is to reduce it to the problem of estimating the rank for the factorization. This is the statistical model selection problem. As statistical model selection, we propose a dimensionality selection based on the minimum description length principle. It chooses the dimensionality that minimizes the total code length required for encoding the total data. The shortest code length is difficult to compute in general. We developed an efficient method for calculating code lengths using what we call the sequentially normalized maximum likelihood coding in combination with important sampling technique. Here is an experimental result. We used benchmark data sets called Text8 and Wikipedia. For them, the dimensionality were determined manually by experts. Our method was able to successfully choose the dimensionalities which are closer to the ones determined by the experts, indicated by NLP tasks. They are significantly closer than the methods for comparison, including existing model selection criteria such as cross-validation, AIC, BIC, PIP, etc. Therefore, using our method, you can systematically choose the optimal dimensionality rather than manually. This is the first work that proposed the dimensionality selection for word embedding from the view of statistical model selection. We have proposed a novel method for selecting the best dimensionality for word embedding. On the basis of the minimum description length principle, we developed an algorithm for calculating the sequentially normalized maximum code length to select the best dimensionality. Our method is so efficient that it can be applied to natural language domain. Our method has the ability to choose a desirable dimensionality in terms of significant closeness of optimal dimensionality in NLP tasks without a holdout test dataset.